Since the magnetic force is always perpendicular to the charge's velocity, and let's just put the equation up here again so you see why that's true. Force is QV cross B. Force is always going to be perpendicular to the velocity. What kind of force is that? That is a center-seeking force. That will result in centripetal motion. The charge will move in a circle. So if we inject an electron with velocity v into the magnetic field on the right here, okay, here's its initial velocity, it will have a direction of a magnetic force directed to the right towards the middle of the circle. Now if you just use the right-hand rule and you came up with a force to the left, what did you forget to do? Flip the direction of the force because it's a negative charge. So as the charge has a force this way, it'll start pulling it like that, and then again the force will be to the right. No matter where it goes, the force will be to the right, and that just defines circular motion. And what kind of motion do we have, clockwise or counterclockwise? This would be clockwise. If we put a positive particle there with the magnetic field into the page, we would get counterclockwise. Can you see the relationship of the magnetic force to the gravitational force here? The electron's motion in the magnetic field resembles a planet moving about the sun. Now let's go back to gravity. What happens to the speed of planets as they orbit? So based on that, predict what will happen to the speed of the electron in the magnetic field. For a planet in circular motion about the sun, the force is always perpendicular to the planet's motion. Thus, no work is done on the planet by the gravitational force, and since we have the good old work energy equation, so we have kinetic energy plus work equals final kinetic energy, if there's no work done, the speed doesn't change. Speed stays constant. The same is true for a charged particle moving in a magnetic field that's perpendicular to its original motion. In both cases, however, the velocity keeps changing, right? Because velocity has magnitude and direction, but the speed is constant.